Today we're going to talk about model view controller, that design pattern. And specifically today, our demonstration will deal with the view controller interaction. And in the next demonstration, we'll add the model and talk about some classes that are used in iOS. We're going to be using something called a zib file today. It's called a nib or a zib file. The zib is an uncompiled XML file, actually. The nib is that compiled version of that file. And what those files do is specify the user interface on the view. And then we'll talk more about outlets and actions. We'll use them in our example, of course. And a little bit more about actions and how you can have more than one control firing the same action. So the model in Model View Controller is a class or group of classes that handles the data for the application. It's aware of the data, but it's not aware of the interactions with that data. It's aware of everything about the data, but about absolutely nothing else. And I say here it's usually instantiated by a controller. The controller that's instantiating it is the view controller. So in Model View Controller, we have one controller or a series of controllers in a more complicated application. All of the views and all of the models are controlled by those controllers. So if we think about having a game, the model would be modeling the data of that game, the map itself in XYZ coordinates, enemy statistics, character statistics, movement coordinates, and so forth. Everything about the data of our application would be handled by the model. The view, on the other hand, is the user interface. It's what the user interacts with the application with. It's owned and operated by the controller, just as the model is. And it handles those objects of the model, but it does so through the controller. In other words, for our game example, we would show the map and the positions of entities in the view, but the actual map as an abstract object and those positions and statistics of our entities would be contained within the model. The interaction, all interaction, is done through the controller. So the controller then serves as a bridge between the model and the view, but it also controls both the model and the view. The model nor the view speak directly to the controller. The controller does speak directly to the model and the view. The important thing to remember here is that iOS and programming for iOS is designed with that model view controller design pattern in mind. If you try to do an application, write an application in an ad hoc manner, throwing things at the application and making it just work without thinking about model view controller in the back of your mind as you're doing this, you'll get into trouble later when it comes time to make some changes to your application or extend its functionality. So I have a slide here that shows this graphically. And we can see the controller's arrows are going down to the model and the view. This indicates that the controller does communicate with the model and the view. There is no connection here between the model and the view at all. The model and the view together don't communicate. All communication is done by the controller. The view knows how to draw itself, and that's really all it knows. And anything that happens on the view that needs to be responded to by the controller, we deal with through those target action and delegation design patterns that we talked about last time. The controller instantiates the model because the controller owns the model in that case. The model knows everything about the data and operations, but it doesn't know anything about what it's going to be used for. This is a way that we enforce encapsulation in our object-oriented design. The model is aware of itself, but the controller actually controls it. In this way, we can have several models that are interchanged, and if we write them correctly, we can change our model, and the controller, which doesn't really care how the model implements its function, can use different models at different times. This idea is polymorphism. So we're going to have a demo, and we're going to begin writing a calculator. And in future presentations, the next few presentations, we'll finish this calculator. But this version is only going to store numbers in the controller. And really what it's going to do is store numbers in a label that's on our view. The view then will contain a display and 10 numeric buttons. Later we'll add an entry button and some functions, operations, that the calculator controller will use to call the model with. The model will store the value and it will also conduct those operations, and the controller will instantiate and operate that model. The controller also responds to button presses in the view, and it updates the label in the view. So we're going to start now with a slightly different approach. Instead of creating a view-based or single view application, as it's called in iOS 5, we're going to create an empty application to which we will add a controller and a zip file for the view. We'll add the model in the next presentation. So let's get started. I'm going to run Xcode. It takes a moment to come up. And we're going to create a new Xcode project. And I'll move this over. And instead of creating a single view application, as we've done before, we're going to create an empty application. And we'll name our application Calculator. Make sure I spell it right. And we'll create it in the appropriate place. And it comes up. And we'll see that we have an app delegate. And we also have our main file, in addition to some supporting files that we'll talk about later. But we don't have a controller, we don't have a view, so we're going to go ahead and create those now. First thing we'll create is our controller. So File, New, and then New File. And we get a selection of things that we can create. Now, the controller subclass is in the Cocoa Touch classes under iOS. UI View Controller Subclass. Next. And we will call this Calculator View Controller. Now, we do have an option to create the zib here, but actually we're going to create it on our own. We'll click Next and save it in our project. And there we go. We get both the header file and the implementation file. Now, we're going to edit the header file, and we already know that we're going to need a display, which is going to be a UI label, and it'll be an outlet. So that will be a property. We're going to use our strong, non-atomic, and it is an outlet, an instance of UI label that we'll call display. We're also going to need an action, and that action is going to respond to a button press. Specifically, in our application today, a digit press. So we'll call this digit pressed. And because we know that the only time that this is going to work is when we press a UI button, we'll make this sender a pointer to UI button. Sender is the button that was pressed. In our implementation file, because we have a property, we need to go ahead and synthesize that property. And that property is called, remember, display. And then also, we need to specify our action. And that action, remember, is called digit pressed. And for now, we'll just have an empty method body. And we'll flesh this out later. And this error means that I forgot the semicolon on the end of this line. Okay. Now we've got a controller, but we do not yet have a view. So let's go ahead and do that. File, New File. Now these are user interface objects, and the view is a user interface object. We could go ahead and create an empty zib and add a view to it, but for purposes of this demonstration, we're going to use an empty view, or an empty zib with a view already on it. This selector is important. If you've been programming for iPad, you want to make sure that if you're programming for iPhone, that you use an iPhone's view. If you use an iPad view, then you'll get a view with the metrics of an iPad, which is not what we want. So we use iPhone, and we're going to call this calculator view. This is the view as opposed to the controller. And we see that this creates a nib file, actually a zib file, and we talked about that a little bit before. We'll scoot this over. And now we need to hook up some things. What we've got is a controller and a view, but they're not hooked up in any way. Also, this controller really should be a subclass of UI view controller and not, as it states here, a subclass of NS object. So we want to use our calculator view controller as files owner. Files owner is the owner of the view. The other thing we want to do is if we right-click files owner and look at its various properties, we want its view to be this specific view. So we drag from the view dot over to the view, and now if we look at the view, we will see that this view is attached to files owner. Likewise, files owner's view is now this view. There's one other hookup that we need to make, a very important hookup. If we look at our app delegate is showing the main window, but the view of the calculator view controller's view needs to be added to that main window. Otherwise, it won't display. So that view controller needs to be a property. So we're going to add that property. Again, strong and non-atomic. In order to get that controller, we're going to need to import its header. And now we can instantiate an object of class calculator view controller, and we'll just call that object root view controller. We could call it anything we want, but root view controller is traditional here. After in our application did finish launching with options delegate, we want to instantiate that controller. First, it's a property. We must synthesize it. Then we say root view controller, and then it's a calculator view controller that we were allocating memory on the heap for, and then we want to initialize it. Now the method we use to initialize a view controller is called init with nibname bundle. The nib name is the name of the nib file that we're using for the view controller. Now we've already specified that. We have said that calculator view is the view of calculator view controller, and we did that in the zib file. So we can say nil, which will take the default. The bundle is the application bundle, so we'll just say nil because that's the default. And after we've got that root view controller has a property called view, and that view is the zib file that we're using to present our data. So the next thing we need to do is add that view as a subview of self.window. We have a method called addSubView, and that view is going to be the root view controller's view. And now we're done. So now when the application runs, the app delegate will instantiate the root view controller and add its view as a subview of the window. One other thing we need to do, of course, it being a calculator, we need a user interface. We'll drag out a label. We'll go to the properties, and we'll set this label's text size as something large enough to see. I'm using the value 32, system font of size 32. And then I'm going to right justify the label. And because calculator doesn't say label, at the top. I'm just going to get rid of that for now. Later we'll add a 0 here. And then I'm going to need a series of buttons, and these buttons are going to be our digit pressed buttons. So now I'm going to make these 64 by 64, and the reason for that is a 64 wide button will go 4 times across with nothing left over. This button, each button, is going to have a system font of size 32, so I resize the font. And it's also, each button is going to be hooked up, so I'm control and clicking the button to Files Owner, and it's going to be digit pressed. Also, Files Owner, I'm controlling and clicking Files Owner and dragging to the label, and that is our display. So the outlet is this label, and each action is going to be fired by one of these buttons. Having done that, I can now copy a button and paste it, and I'm going to need 10 buttons total. So I'm pasting these buttons in a matrix. And the beauty of doing it this way, setting all the properties first on these buttons, is that every property of these buttons will now be inherited by every copy I make, including the action touch up inside goes to digit pressed. If I had made all 9 buttons and then changed their properties, I would have to hook up that action 10 times. So now I'm giving each of these buttons their appropriate digit. And there we go. So when we press a digit, the idea is that that digit will be added to what's already in the display. Well, that's a great idea, but we can see that we haven't done that yet. When we press a digit, nothing happens. So this is actually very simple to do. The display has a property called text, and it is an NSString object. So we will take that display.text property, and actually we should use the setter and the getter. This should be self.display.text. Remember that property and synthesize give us setters and getters. So self.display.text, and then we're going to use a method of NSString directly on NSString. This is a class method. Now we're going to talk about NSString a lot in our next presentation, but for now we have a class method on NSString called string with format. And string with format takes a formatting string and then substitutes values that we pass into it, just like printf or scanf in straight C would do. So I'll close the sidebar so we have more room. And our format is going to be an NSString, @ for NSString, and then %@, %@. Now, %@ is a format specifier that's new if you've been programming only in C. In Objective-C, %@ says, give me the descriptor of what I'm passing into it. The descriptor of an NSString is the string itself. So the first thing we want to do is take whatever in display.text already and display it. The next thing we want to do is we want to get the text off of the button. And that text on the button is in sender.titleLabel.text. This is also an NSString. And now, when we run our application, and this will take a moment to compile and run, but when we run our application and press a digit button, this digit pressed will be called and placed in the display at the end. So display.text now is 789, and we can see that when digit pressed is called, it becomes 789 and then whatever the title label on the button was. So 7892, 78921, 7789213, and so forth. So this is our presentation for today. We'll be extending this calculator in future presentations. Thank you.